Hi, this is my traffic.py problem set for CS50AI. I'll go ahead and run the program. You'll notice I just have a few terminal outputs just indicating where images are being loaded from, and afterwards how many images were loaded. I didn't include really any extra checks other than what was specified in the project, but that could be useful to ensure that there's no breakage if folder structure is different or if someone's system is a little bit different. So when the images are loaded, obviously we use the load data function, iterating through folders and files, opening all the images and resizing them to 30 pixels by 30 pixels. I use the os.path.join to ensure that the folder separators would be applicable to any operating system. That loading images function returns a tuple of images and labels for sklearn to split into a training and testing group where the test size is 0.4. Here is all the output from running our model. We'll talk about this a little bit later. So I went ahead and experimented with the parameters in the neural network. Initially, I just started with what was used in handwriting.py in the lecture, and then adjusted the parameters just to see what would happen. Changed the number of convolutional layers, the filter size, the number of filters. Also looked at the number of pooling layers, the pool size, number of hidden layers, number of units in the hidden layer, and the dropout percentage. Afterwards, I ranked these by accuracy and by speed. Obviously, there's going to be a trade-off between accuracy and speed. I did find, which was surprising, I'm not sure why this is, but when I did remove the pooling layer and the hidden layer, both speed and accuracy increased from what was used in handwriting.py, which is a bit surprising. I'm sure there's a reason for that. So I decided to use a few different parameters from what was used in handwriting.py for my neural net model. I used 2 convolutional layers instead of 1. I found that this increased accuracy quite a bit, obviously with the trade-off of speed. There's 32 filters in each with a 3x3 kernel. I have 1 pooling layer with a size of 2x2. The layers are flattened, and then I have 1 hidden layer. And I increased it to 256 units. I found that improved accuracy, again at the expense of cost compared to handwriting.py. And I stayed with 50% dropout. I found that if I changed that to 25% or 75%, accuracy went down substantially. And then there are 43 output units for each of the sign types. So if we look at the output from the training session, there are 10 training runs. You'll see that as we progress through the training, losses decrease, accuracy increases. I ended up with a final accuracy of just over 99%. But again, this neural net is somewhat slow in its training, where it was about 1 second per epoch. So that's quite substantial, but again, that could just be changed based on the project's goals and needs. So that's my neural network. It was a fun project.